Garbage collection in Python for Linux. I'm a little puzzled how Python allocates memory and garbage collects, and how that is platform specific. For example, when we compare the following two code snippets. Snippet A. Snippet B. Snippet A returns true because when Python allocates memory, it allocates it in the same location for the first test, and in different locations in the second test, which is why their memory locations are different. But apparently system performance or platform impacts this, because when I tried this on a larger scale, a friend on a Mac tried this, and it ran until the end. When I ran it on a bunch of Linux VMS, it would invariably return, but at different times, on different VMS. Is this because of the scheduling of the garbage collection in Python? Was it because my Linux VMS had less processing speed than the Mac, or does the Linux Python implementation garbage collect differently?
Python uses two strategies for memory management: reference counting, mark and sweep garbage collection. Allocation is in general done via the platform's malloc/free functions and inherits the performance characteristics of the underlying runtime. If memory is reused is decided by the operating system. There are some objects which are pulled by the Python VM. Your example does, however, not trigger the real GC algorithm. This is only used to collect cycles. Your long string gets deallocated as soon as the last reference is dropped.
The garbage collector just uses whatever space is convenient. There are lots of different garbage collection strategies, and things are also affected by parameters, different platforms, memory usage, phase of the moon, etc. Trying to guess how the interpreter will happen to allocate particular objects is just a waste of time.
It happens because Python caches small integers and strings. Large strings, stored in variables not cached. Large strings, not stored in variables, looks like cached. Small strings, cached. Small integers, cached. Large integers, stored in variables, not cached. Not stored, cached.
If you want to see more, please press the subscribe.